Hi guys, this is module 14. It's going over the perpendicular bisector. So things that you need to know about the perpendicular bisector is one, perpendicular, so that means crossing at a right angle, and bisector means splits whatever is down at the bottom in half. So this half is equal to that half. So the perpendicular bisector means that it splits something in half and is at a right angle to it. So you have all these examples here. So you have this one here that is a line that bisects AB. This is a ray that is a perpendicular bisector to AB. And then this is a segment in bisecting the segment, being the perpendicular bisector of that segment. And the main thing that you need to know is that, like, that point where it crosses is the midpoint of the whole thing. So it's equidistant, or the same distance from the end. So like from here to here is the same as from there to there. And they have this whole big proof of it, which is fantastic. 11 steps. I'm sorry about proofs, but that's how it is. But then there are more interesting things that you can do with it, like this. This is the first problem. So in this thing, we have that NR is perpendicular to MP. It says that NP is 6. MR is 2.9. What is the length of NM? So again, they did not do very many interesting things with this. Like if they told us that this was NP, well, I guess if they told us this was NP, then we would know that these two triangles are the same. So let me just kind of quickly go through the logic here. And it's not a proof, it's just simply saying, can we actually assume that? This triangle on this half and that triangle on that half, they share this line right here, right? So we know that both of those, that's congruent to itself. They're both right angles. And then if that's a bisector, then this side equals that side. So we could say by side, angle, side, they're the same. And therefore, N and P have to be the same. But that's not, like, way better than doing a proof, right? Or here's this one, interpret a situation where you'd have to use it. So we have this crazy thing. Olivia, an architect, designs a window frame for a building as shown in the image. So I don't know which one is the image, the window, but we're going to go with it. She wants to put C, D, and E to be equidistant from point A and B. Which statement will make sure that C, D, and E are equidistant from A and B? So I would say that they would have to, CF should meet at a point that is equidistant from AB. That's good. CF should meet at a point that's equidistant from A to B. That's true. Oh, at a right angle, that's equidistant. And so because that's the perpendicular bisector. Okay, so now the problems. So Klaus's house is located at point K. His friend's Jenny's house is located at point G. The public library and science museum, which they often visit together, are at point L for library and M for museum. Klaus and Jenny think that the library is the same distance from both of their houses and that the museum is the same distance from their other houses. So which statement proves? So again, we're looking for perpendicular and we're looking for like bisector, something about equidistant. So the street with the library and museum crosses the street with the houses at 90-degree angles and is equidistant for both houses. So that sounds like it's perfect because it's talking about 90 degrees, that's perpendicular, and equidistant, that would be bisector. So that looks good. We could read the rest of them. I'm not gonna. Use the diagram and information to complete the proof. Given that AD is the perpendicular bisector of BC, we want to prove that angle B is the same as angle D. So that's kind of like what we talked about earlier. Every proof always starts with given. Then we would say that AB is congruent to AC. AB congruent to AC. And DB is congruent to that. So that, what I would say, is the perpendicular bisector theorem. Is that correct? Definition. Yep, I'd have to do that. Then AB is congruent to AC. That's definition of congruence. Not triangles, just definition of congruence. Segments. Okay, and then AD would have to be congruent to itself. That's reflexive property. Oops. And then they're the same by the only one that's in here, side, side, side. So they went on about it by angles. So B is congruent to C by definition of congruent triangles. Okay. There we go. That was 14.1. I'll just go right into 14.2 because I can. Here we go. Move my little picture. So fun to see myself. It's not fun to see myself. I don't enjoy it. So then we have the converse of it. It's saying that if you have something that intersects a segment and it splits it in half and is perpendicular to it, it is the perpendicular bisector. So that's what the converse says. So if it is equidistant, then if a point is equidistant from the endpoints of a segment, equidistant from the endpoints of a segment, then the point is on. Then the point is on the perpendicular bisector. So bisector means anything that splits it in half. The perpendicular bisector is specifically a line, a ray, or a segment that bisects it and is perpendicular. So anything on that perpendicular bisector will bisect the segment, like anything that connects to it. So we have this thing. Okay, so anything on that line. So then we come to this and we have a side, an angle that we don't know if it matches that one, and a side. But we know that both triangles share this side. So by side, 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 those triangles are congruent, right? So now we want to know what is the measure of BDA. Well, if they're the same and those are the same, that means it's the perpendicular bisector. So the angle would have to be perpendicular, like that. Submit. And then write a proof of the converse. So good, you guys get to, let's do that. And you guys get to follow me. It just had everything. Okay, I don't want to go through that because I don't like proofs and I don't think that you need to know proofs. Sorry. Okay, use this figure to complete the sentence. So if line E is the perpendicular bisector of BC and BD is equal to 2, then CD also has to be 2. Good. So then next one. In the following, so BA is congruent to CA and D is on BC. So if BD is 3, then CD must also be 3. That's pretty easy. And then next part is the checkpoint. I'll even do the checkpoint for you so that all of 14 can be done. And the reason why I'm doing this is so that you can, if you need to, you could catch up. If I think that most people who are watching this are behind. So I'm doing it just so that you can catch up, not as a normal thing. Okay, so the following design shows a structure that supports the roof of a house. It is in the shape of a triangle. So AB is 8.2, BD is 6, CD is 6. The measure of ADC is 90. So therefore, I know it's a perpendicular bisector. So which figure is a perpendicular bisector of ABC? And so it would have to be AD is the perpendicular bisector. Okay. And the following figure, AC is 4 and CB is 4. So if AC and AE are 4, then that forces this thing right here to be a right angle. So we know that AE is congruent to EB because it's the perpendicular bisector. Measure of angle ACE, so let's see. ACE, is it congruent to measure of angle BEC? No. BEC is 90. AED is 90. Yep. CE is congruent to ED. We don't know that. The measure of angle CAE is 45. We also don't know that. Do we know that? Let me just think here. We have that one. So AC is 4 and CB is 4. Yeah, we don't know if that was true. Okay. Then use this figure to answer the question. So Allison drew a map of where she and her friends live. Allison's house is at point A, and her friends live at point B, C, and D. She only wrote some of the distance in the blocks on the map. Also, AD is the perpendicular bisector of BC. Alison wants to know the distance between her house and point C. So she knows that one. So then that her house and point C would have to be the same. It'd be that 4.24. Then in the following figure, BA is the perpendicular bisector. So here's BA is the perpendicular bisector of CDC. And if BD is 3.7 and AC is 4.1, how long is BC? So let's see, BD and BC would have to go with each other because BA is the perpendicular bisector of BD. So it'd have to be 3.7. Then Aisha constructs the wood frame of a paper kite. She crosses two sticks as shown in the figure. She wants to connect the sticks at the edges of the paper have certain measures. She wants KM to equal KN and ML to equal NL. How should she position the sticks? So at 90 degrees, right? So place KL and an acute angle, nope. Place KL at a point that is not, nope. Place KL at a right angle on MN and bisects MN. Yep, perpendicular bisector. Okay, let's see how I did. 100%. Okay,